All right, 9.3 is all about two-way tables. So what is a two-way table? A two-way table is something that displays two categories of data collected from the same source. So you can randomly survey students in your school about their grades in the last test and whether they studied, and the two-way table shows the results. So each entry in a table is called a joint frequency. Joint meaning two things are happening at one time. Okay, so here is the table I was just referring to. This is the amount of students who studied and did not study, and those who passed and failed. Okay, so example 1 is asking how many of the students in the survey studied for the test, so I'm only looking at this column right here, and passed. So studied and passed, that would be 21 students. And I missed a vocab word, so you're going to have to bear with me and write them down. A marginal frequency, is the sum of the rows. Okay, so it's sum of rows in columns. Okay, so the marginal frequency of passed would be 23. The marginal frequency of failed would be 7. 8 did not study and 22 studied. Okay, and then you can say the total amount of students is 22 plus 8 is 30, and these should equal up. So 23 plus 7 is 30, 22 plus 8 is 30, and we're good to go. Okay, so you basically make a totals column. And that's what the next question is about. So find and interpret the marginal frequencies for the study. So we are going to make this look a little prettier. So this is total. We're going to extend our table. And total. And extend the table here. And so the total amount of students who studied was 22. The amount of students who did not study was 8. 23 passed, 7 failed, and then this is where you put the 30, where you add up the totals of the things that you totaled. Okay, so that is example 2, interpreting the marginal frequencies. So we created a new column, and then we added the entries, which are the numbers. So on your own, you randomly surveyed students in the cafeteria about their plans for a football game and a school dance. Okay, so those are 2 data points, whether they went to the football game and whether they went to the dance. So the two-way table below here shows our results. So A says how many students will attend the dance but not the football game. So they're not attending the football game, so I'm here and attended the dance. That would be only 5 students. Part B, I have to interpret the marginal frequencies, and unfortunately I don't have very much room here. Let me pause and move my screen real quick. Okay, so this is total, and this is total. So the amount of students that attended the football game is 35 plus 16, which is 51. So 51 students attended and 25 did not attend the football game. For the dance, 40 people attended and 36 people did not attend. And the total amount of students that were surveyed should be 76. The way we can check that we added correctly is 40 plus 36 is 76. 51 plus 25 is also 76. So find and interpret, that's our favorite word, interpret the marginal frequencies for the survey. So my main things here are 51 total students. I would say 25 are not attending the football game. I would also say 40 will attend the dance. And 36 will not attend dance. And I also guess you could say, 51 students will attend game. Should have been up here. And how many students overall? There were 76 students overall. So that would be interpreting the table. Second part of this is you have to make your own two-way table. So you randomly surveyed the students between the ages of 12 and 17 about whether they ride the bus. The results are shown. So here we go, ride buses and do not ride buses. That's our first point of data. So I would start there by saying, I'm going to do it on the side over here. So I have rides bus and does not ride bus. So, and then it's broken into, oops, let me go back. It's broken into ages. So up here is going to be their age. So this is 12 to 13 is our first group. Second group is 14 to 15. And third group is 16 to 17. So the amount that ride the bus that are 12 and 13 is 5, 10, 15, 24. And I just counted up these tallies right here. The amount that ride the bus that are 14 to 15 are 5, 10, 12. The amount of people who ride the bus 16 to 17 is 5, 10, 14. Now I'm looking down here for people who do not ride the bus for my second column. 12 to 13-year-olds, 5, 10, 15, 16 do not ride the bus, who are 12 to 13. 13 do not ride the bus, who are 14 to 15, which is right there. 16 to 17-year-olds that do not ride the bus are 21. Okay, so make a two-way table. Now I have to include my marginal frequencies, which are my totals. And the amount of students who ride the bus, if I add 24, 12, and 14, I have 50 students who ride the bus, and I have 50 students who do not ride the bus, for a total of 100. And people ages 12 to 13, I have 40 students. 12 to 13, I have 25 students. And 14 to 21, I have 35 students. And then 40 plus 25 plus 35 is also 100. And that is how you make a frequency table. Or excuse me, a two-way table. Example 4. So we're going to use the table that we made in example 3 to answer these questions. So it says what percent, for each age group, what percent of the students in the survey ride the bus to school or do not ride the bus to school. Organize the results in a two-way table. So this is for each age group. So once again, I'm going to have my same two-way table with age on top. So 12 to 13, 13 to 14, and, what did I just do? No, erase that. This should have been 12 to 13 and 14 to 15 and 16 to 17. And this is going to be my ride and does not ride. And we're doing percentages. So if I look back at this table, 24 out of 40 students ride the bus, ages 12 to 13. So that is 60%. Wrong way. So the percent that rides is 60%, which means the percent that doesn't ride is going to be 40%, which is also 16 divided by 40. Okay? 14 to 15, 12 out of 25 ride. So that's 48%. So 48% rides. 52% does not ride. And then 16 to 17, I have 14 out of 35 who ride the bus for a percent of 40%. And if 40% ride, that means 60% do not ride. So that would be my the percentages in a two-way table. So does the table in part A show a relationship between whether age and whether students ride the bus? And that answer is yes. As age increases, I'm going to shorten this, as age increases, bus riding decreases. All right, do this problem on your own, and we will check it in class tomorrow. See you later.